Now we will be going with the continuation of this chapter. So in this class we will be talking about refraction at the curved surface. So till now we have seen reflection at the plane surface, reflection at the curved surface, and in the other class we have seen refraction at the plane surface. Now we will be going with refraction at the curved surface. Before going to that, let me talk about a question which was taken in the last class in a little simpler way. So this is the question: a prism of root 2, so critical angle is going to be 45. So in option A, if the angle of the prism is 40 degrees, what will happen? So if the angle of the prism is 40 degrees, okay, so let me go with this explanation. So critical angle is 45, R1 plus R2 is A. So in the first case, R2 maximum, for R2 to be maximum, R1 has to be minimum is 0. So when you will send it perpendicular to the surface, so R2 will be equals to A, so that is 40 degrees. So R2 maximum itself will go out of the surface. So there won't be any total internal reflection. So R2 maximum itself can go out without total internally reflecting. So all the R2s, and no matter what is the R2, it will be going out. Now in the second case, maximum, for R2 to be maximum, R1 will be minimum. So R2 maximum equals to A, 80. So 80 is greater than critical angle, so there will be total internal reflection. What about R2 minimum? R2 minimum will happen when R1 is maximum. R1 maximum is 45. So 80 minus 45, 35. So R2 value ranges between 35 to 80. So 35 to 45, they will be going out. 45 to 80, they will be total internally reflecting. Some will go out, some will total internally reflect. In the third case, this minimum will happen when this is maximum, that is 45. So 110 minus 100 minus 45 will be 55, so which is greater than critical angle. R2 minimum itself is greater than critical angle, so R2 minimum, for minimum angle it will total internally reflect, so any angle it will total internally reflect. Now generalized condition we have seen it, when R2 minimum is greater than critical angle, it will total, all the rays will be total internally reflecting. R2 minimum will happen when R1 is maximum, that is R2 minimum is A minus critical angle. So when R2 minimum is greater than critical angle, total internal reflection will happen, and this is A minus C, this is A minus C, right? A minus C is greater than C, then total internal reflection will happen, that is when angle of the prism is greater than twice of the critical angle, all the rays will be total internally reflected back, and we will say there is no emergence. Yes, now going to the refraction at the spherical surface, we are not going to do the derivation, we will be just looking at the result. Refraction at the spherical surface, if there is an object, I need at least two rays to trace the image. So one ray going and hitting, and this is the center, this is the normal, so angle of incidence is 0, so angle of refraction will be 0. Now the other ray which is going like this is the center and this is the normal, so it will be refracting towards the, assuming like this mu is greater, so it will be bending towards the normal, and yeah, so these two rays they are converging here, this will be the image getting formed. So this is the object distance, this is the image distance. Now we will be going with only small angle approximation. So what we will be getting, the result is mu r by v minus mu I by u equals to mu r minus mu I by r. So what is mu r? Mu r is the refracted ray medium, Mu I is incident ray medium, u is object distance, v is image distance. Now r is radius of curvature. For this particular figure, this is the incident ray, there is positive direction, so radius of curvature is positive for this particular figure. What will happen if r tends to infinity? So this is going to become plane. When this is going to become plane, this will tend to 0. So when this tends to 0, I can say mu r by v equals to mu I by u. Now this thing we can apply at refraction at the plane surface, that is when we have seen bird and water case. So in that case also we can apply this, instead of remembering d by mu into d, we will get the answer. Right, so magnification will be given by v by mu r by u by mu I. Image distance by refractive index of refracted ray medium by object distance by incident, mu of incident medium, right? So refracted ray will give you image, so you can remember it that way. Anyway, so refraction at the curved surface, so this is how you will be tracing the image, and this is the magnification. So you need to remember this. Based on this I will be deriving lens formulae later. Now yeah, so we need rays to trace the image, so there are not many what we can draw, but one thing we can say, like if something is passing through the center, that will be hitting the normal at angle 0, so it will be going undeviated. So anyway, let us see how to trace the image. by using formula. So object distance is 25, object is here, incident ray is going this way, so this direction is positive, this direction is negative. So we need to use mu r by v minus mu I by u equals to mu r minus mu I by r. Incident ray medium is 1, incident ray medium is 1, refracted ray medium is 1.5. So I will be putting 1.5, 1, so 1.5 minus 1 by this image distance. We need to find object distance. Object distance is 25. This is positive direction, this is negative direction. So object is at minus 25 and radius of curvature. This is positive direction and this radius is plus 20. So when you substitute, you will be getting image is minus 100. Image will be formed at minus 100. The meaning of minus 100 is image will be formed on this side. This is plus, this is minus. So if image is formed on this side, the meaning is it is virtual, because the rays, if they are converging, they will converge only on that side. The rays are going forwards, right? So if they are converging, they will converge only on that side. So if we are getting the rays are converging on this side, the meaning is they will be diverging and imaginarily they will be extending and meeting here. So image is virtual. Okay, you can look into the question from the package. An object P is placed in air in front of thin equiconvex lens. Equiconvex, so both sides radius of curvature will be same. Of focal length 30 centimeter. So you just take it, they have given focal length and refractive index 3/2. So that will give you radius of curvature 30. So that I will prove you later. So you, for time being, you take it as both radius of curvature is 30 centimeter. So this medium is of refractive index 3/2 and this is 4/3. So take the radius of curvature is 30 centimeter. Then what will happen? This is the object, rays will pass through this and they will refract here. Now those rays will refract again here. So there are two refractions happening. So let us see what will happen here, the first refraction. So this is the formula. Now if I want to use the formula, the first refraction, mu r by, this formula. So incident ray, this is the incident ray. So this direction is positive, this direction is negative. Object distance is minus 90 given in the question. This is 90. This is positive direction, this is negative direction. So this distance is minus 90. Now incident ray medium is 1, refracted ray medium is 3/2. Incident ray medium is 1, refracted ray medium is 3/2. So 3/2 minus 1 you will be getting. Now radius of curvature. Now this fills a part of sphere whose center is that side. So radius of curvature is positive and I asked you to take it as 30. So refracted ray medium, incident ray medium, radius of curvature, object distance. From here you will get image distance is 270. The meaning is if there is only 3/2 medium, this entire thing, then the rays would have converged somewhere here whose distance is 270. But the rays are not going to converge there because they are going to undergo refraction. So these rays will act as incident rays for this curvature and there will be refraction. So these rays, they are incidenting here. Now those rays, when you extend them, they are meeting here. Incident ray direction is this way, so this direction is positive, this direction is negative. Now object distance is positive, and as the thickness is very small, I can say distance from here to here, if it is 270, distance from here to here also is almost 270. So when we do that, incident ray refractive index is 3/2, refractive medium is 4/3, 3/2, 4/3, 3/2, 4/3. So incident ray medium 3/2, refracted ray medium 4/3. Refracted ray medium by image distance equals to incident ray medium by object distance. Now object distance is plus 270, it is in the positive direction. Now actually the object is virtual, they are supposed to meet there, object is virtual. Now radius of curvature, this is positive direction, this is a part of sphere of radius 30, but this side it is minus 30. When you solve for it, you will get 120, plus 120. The meaning of plus 120 is they will be converging here, and if it is plus 120, the meaning is it is real image because they are actually going to converge. So real image will be forming at a distance 120, right? Going to the next question, a glass slab of refractive index 2 has left spherical surface of radius 10 centimeter and right surface plane, right one plane. From both the surfaces, refraction as well as reflection takes place. A point object P is placed at a distance 15 centimeter from point O. So now we need to talk about the images. See, the rays which are going like this, they will be refracted and this guy will see them. And there will be partial reflection also, they said. So we will talk about reflection later. If we talk about only refraction, these rays after refracting, this guy will see. These rays after refraction, this guy will see. Now if we talk about the reflection here, these rays will reflect and they will go like this and they will refract and this guy can see them. If we talk about the reflection here, these rays will reflect here and those will come here and they will refract and this guy can see them. So basically these are the things we need to do. We will go with the refraction first. Okay, so if I want to talk about refraction here, So this is the object and this is the incident ray. Incident ray is going this way, so this direction is positive, this direction is negative. So incident ray medium is 2, refracted ray medium is 1. So incident ray medium, refracted ray medium, object distance is minus 15. This is positive direction, this is negative direction. Incident ray medium by object distance, refracted ray medium by image distance 1 minus 2 by radius of curvature. Radius of curvature, this side is positive, this side is negative, radius of curvature is negative 10. When you do that, you will get V is minus 30. V is minus 30. So the meaning is this guy will be feeling those refracted rays were coming from somewhere distance 30. So that is virtual image, because this guy, if image is forming that side, the rays won't be actually meeting. So that is virtual image. Now if we talk about the refraction here, it's here radius of curvature is infinity, so I can go with this is 0, so mu r by V equals to mu I by u. Mu r, refracted ray medium index by V equals to incident ray medium by object distance, which is this is positive direction, this is negative direction, so this is minus 5. From here we will be measuring the distance, which is minus 5. From there we will be getting V is minus 10 by 3. The meaning is image will be formed somewhere here, that is 3.33 minus 3.33. Again it is virtual image, because the rays are going this way, but this guy is feeling those rays are going to converge here, virtual image. So that's about the refraction. This is the refraction here, this is the refraction here. Now if I talk about reflection here and those rays coming here and getting refracted, if this distance is 5, then after reflection we will be feeling like those rays, the reflected rays, they will be meeting here, which is that distance 5. Object distance is 5, image distance will be 5, right? So the rays which are reflected here will be feeling like they are coming from here. They are coming from here. So for this guy will act like an object. Object distance is 20 plus 5, 25. What about the direction? This is positive direction, incident ray is going this way. So this is positive direction, this is negative direction, object distance is minus 25. So we will be using refraction at the curved surface. Incident ray is going this way, so incident ray medium by object distance, which is minus 25. Refracted ray medium by image distance 1 minus mu by radius of curvature. Incident ray is going this way, so this is a part of sphere whose radius of curvature is negative minus 10. When you do that, you will be getting V is plus 50. The meaning is these rays, they will be converging here, which is at a distance 50. This is a real image, they are actually going to converge. Now talking about the reflection here, rays will be going this way, so this is positive direction, this is negative direction. When I use mirror formula, 1 by u plus 1 by v equals to 1 by f, u is minus 15 v, and focal length, radius of curvature is minus 10, so focal length will be minus 5. When you solve for it, you will get v is minus 7.5. so image will be formed somewhere here. After reflection, image is getting formed somewhere here. So the meaning is it is actually real image, because reflection is happening, right? So the rays will be actually meeting here. So that's a real image. So that's a real image. Now after reflection, those rays will meet here and they will go like this. And so this will act as an object for this guys. This is 7.5, this is 12.5. So incident rays are going this way. So this direction is positive, this direction is negative. Anyway, we are talking about refraction at the plane surface. So this is going to be 0. So mu r by v equals to mu I by u. Mu r 4 by 3 by v equals to mu I 2 by object distance. This is positive direction, this is negative direction. So by minus 12.5, 2 by minus 12.5. From there you will be getting v is minus 25 by 3. The meaning is image will be formed this side. Image will be formed this side, that is virtual image, because the rays are going this way. If we are feeling that they are converging here, they are supposed to converge here when you extend them. So that's a virtual image, right? So from there you will be getting option C is correct. And apart from that, you can see first guy. This guy is going to see one image which is because of refraction, one image because of the reflection as well as refraction. This guy also is seeing two images. One is directly because of the refraction, one is because of this reflection and the other refraction, and they are forming at the different positions. So this guy will be seeing two images, this guy will be seeing two images, right? Going to the next part, next question. A convex surface of thin concave convex lens. Okay, you will see what does that mean. So these are the shape of the lens generally. These are the names. Convex on both sides, concave on both sides. One side plane, one side convex, one side plane, one side concave. The convex surface of thin concave convex lens of lens. Okay, so you can read the question. I will explain what does the question say. So there is one radius of curvature which is 20, other radius of curvature which is 60, right? 20 and 60, yes. And this medium is, of refractive index 3 by 2. This medium is of refractive index 3 by 2. This is a glass. So this is the lens and you are mirroring this side. So this is the question, and you need to put some object somewhere so that image will be formed at the same point. So let me zoom that part. I am zooming this part and drawing the figure. So there is one radius of curvature which is 20 and other radius of curvature which is 60, and this side it is mirror. So if you keep some object somewhere, then rays must go and image must be formed at the same point. The other way of saying it is, how can the image will be formed at the same point when the rays will be retracing the path. So the ray which you are sending like this, it must hit the mirror normally. So that's the idea. If it hits the mirror normally, then the rays will be coming back as it is and they will retrace the path. So that's the idea we will be going with. Instead of starting from here, we will see what will happen if the rays which are going perpendicularly, if they get refracted, where they are going to meet. So the rays, I am considering the rays which are hitting the mirror perpendicular, which are going from the mirror perpendicularly. So if I extend them imaginarily, they are going to meet at the center because they are perpendicular to the surface, right? So they are going to meet at the center. So if I talk about the refraction here, these are the incident rays and incident rays are going to meet here. So object distance is going to be radius of curvature, which is 20 centimeter. So if I consider the refraction here, then the object distance is 20 centimeter. I need to find what is the image distance. So refracted ray medium, which is 1 by image distance, equals to incident ray medium 3 by 2 by object distance. This is the incident ray direction. So this is positive direction and radius of curvature is 20. So object distance is plus 20. Then 1 minus 3 by 2 by radius of curvature of this thing. Radius of curvature of this thing is plus 60. Plus 60. When you solve for it, you will be getting V is plus 15. The meaning is they will be converging somewhere here of this positive direction, right? So object is virtual object, image is real image. So when you keep the object at 15 centimeter, the rays will go like this. They will divert their path and they will hit the mirror perpendicularly. They will come back as it is, and again there will be reflection and they will meet at the same point. Now you are filling this part with the water. You are filling this part with the water. Now what will happen? Again, we need to see where the object should be placed so that the image will be formed at the same point. So if you send some ray, it will be refracting here, it will be refracting here, and if it hits the mirror perpendicularly, it is going to retrace the path. So that's the idea. So again, I am going to start from here. If I take the rays which are hitting the mirror perpendicularly, if I extend them imaginarily, they are going to meet at the center. So that is, for this refraction, this is going to act as object. This is positive direction, incident rays going this direction, so object distance is plus 20. So incident ray medium is 3 by 2, refracted ray medium is 4 by 3. Incident ray medium, refracted ray medium. Object distance is plus 20. So 4 by 3 minus 3 by 2 by radius of curvature of this thing is plus 60. When you solve for it, you will be getting 240 by 13. So when you send the rays like this, which were supposed to meet at the center, if you consider the refraction here, they will be meeting somewhere here, which is at a distance 240 by 13. But they are not going to meet there because they are going to undergo refraction here also. So for this guy, this will act as object and image will be formed somewhere here. We need to find that image. So if this act as an object distance is going to be 240 by 13 because these are all thin surfaces. So 240 by 13, object distance will be, and it is a plane surface, right? So I can go with mu r by V equals to mu I by U. Mu r, refracted ray is going in the medium 1 by V equals to mu r by V equals to mu I by U. U is 240 by 13, mu I is 4 by 3. Right? So when you solve it, you will be getting V equals to 180 by 13. So these rays after refraction, they will be meeting somewhere here. So the rays which are supposed to meet at 20, after first refraction, they are supposed to meet at 240 by 13, but after second refraction, they will be meeting at 180 by 13. So when you send the rays like this, they will undergo refraction, they will undergo reflection, they will hit the mirror at the perpendicularly, and they are going to refract here, and they are going to retrace the path, and they are going to meet at the same point. So for that, you need to put the object at a distance 180 by 13. In the previous case, you are putting at 15, now you are putting at 180 by 13. So the shift, they are asking the change. 15 minus 180 by 13, that is 15 by 13, right? Now we are talking about the lens, two surfaces, anyway names you can manage by yourself. So this is biconvex, and if both sides the radius is same, we call it as equiconcave. So this is biconvex, and if sides both the sides radius is same, then we will call it as equiconvex. This is, if both sides the ratio is same, we call it as equiconcave. So that's fine, you can manage by yourself. And generally the ray diagram, somehow they are going to look like this. So if the object is real, image is real here, if you notice. here the object is real refracted ray and the image is virtual. Real object, virtual image, so something like that. And in the later section you are going to see, if you send the rays parallelly for this kind of mirror, generally when the outside medium is 1 and inside is glass, then the rays will be converging at some certain point, and we know when you keep the object at infinity and where the image is getting formed, we call it as focus. And when you keep the object at focus, I mean obviously when you are sending the rays like this, they are meeting here. If you send the rays like this, they will go like this. So if you send the rays like this, they will go like this. That's the figure here. When right, it's the same figure. When you send the rays like this, they will go parallel. So that is focus. Now in case of this kind of lens where the inside medium is glass and outside is air, then when you send the rays like this, they are going to diverge, and when you extend them, they are going to meet at some point, which is called as focus. Now this is the other way. When you send the rays like this, they will go parallel. When you send the ray like this, they will go parallel. So where they are supposed to meet here, but they are going to go parallel. That is called as focus. Okay, so how we will be talking about refraction here? Refraction here is happening at two surfaces. Refraction here is happening at two surfaces. This is the ray which is going after refracting. We will be feeling like this ray is coming from here. Now that will go and it will refract. It will refract and we will be feeling that that ray is hitting there. So this is the object and this is the first image getting formed, this is the second image getting formed. So that's the final image. So what we will be doing, we will be considering refraction at this curved surface first, then refraction at this curved surface first, next, then we will be doing some manipulation. Now the good thing is we are talking about thin lens, so the meaning is distance of O1 from here and from here is almost same. So that looks like when we consider the refraction at the first surface. Now when I take the lens, what we are doing is we are taking inside medium is mu2, inside medium is mu2, outside medium is mu1. So when I consider refraction here, then incident ray medium is mu1, refracted ray medium is mu2. When I consider this surface, incident ray medium is mu2, refracted ray medium is mu1. So this is how it looks, refraction at the first curved surface. Refracted ray medium by V1 minus incident ray medium by U equals to this thing, radius of curvature of the first side. Now similarly, this image will act as object for the next guy. So incident ray refractive index by object distance, refracted ray medium by image distance equals to mu1 minus mu2 by radius of curvature of the second one. Here magnification is going to be height of the first image getting formed by height of the object, which is v1 by mu2 by u by mu1. Here magnification is going to be height of the final image by height of the intermediate image getting formed, that is v by mu1 by v1 by mu2. Now if I want to get the total magnification, that is height of the final image by height of the object, I can multiply these two, then hi1 will get cancelled. So total magnification will be m1 into m2. So when I multiply these two, I will be getting mu1, mu2, everything getting cancelled, and I will be getting v by u. So magnification in case of lens is v by u. Take a note of that. That is, in case of mirror it was minus v by u. Now you will be getting plus v by u. Anyway, you can understand it once you see where the images will be getting formed. Now I don't need this, so I will add these two equations, then this will get cancelled. I will be getting mu1 by v minus mu1 by u equals to whatever this thing. Now mu1 I can take it to the other side and I will be getting this form, and this is called as lens maker's formula. Whatever I have put in red box is kind of important, we should be remembering them. Now we know by definition, when you keep the object at infinity, wherever the image will be getting formed, we call it as focus, and that particular length is called as focal length. So from here you can see 1 by f equals to mu2 by mu1 minus 1 into 1 by r1 minus 1 by r2. So generally we don't be writing this thing, we will just substitute this back. This entire thing is 1 by f, so when you substitute it back, you will be getting 1 by v minus 1 by u equals 1 by f. Generally we will be writing this formula. Whenever we need 1 by f, we will use this. So we will use these two instead of this one, and this is called as lens maker's formula, this is called as lens formula. And generally we treat power of converging devices as positive and power of diverging devices will be negative. So, and for mirrors and thin lens, we will be defining power as 1 by focal length magnitude wise. So if they are converging in nature, we will take power is positive, and they are diverging in nature, we will take power as negative. So power is defined as 1 by f magnitude wise. When f is in meters, then power units are going to be diopters. So that's how you need to substitute. Anyway, we will talk about power later. So for time being, we will see how to use this formula. Now, yes. So if this radius of curvature is r1 and r2, if I want to find the focal length, either I can send the rays from this side or this side, we are going to get the same focal length. So I am going to send the rays like this. So if the ray is going this way, so this is positive direction, this is negative direction. So let me say outside medium is 1. So 1 by focal length equals to mu 2 by mu 1. Mu 2 by mu 1, which is mu by 1. Mu by 1 minus 1. Mu 2 by mu 1 minus 1 into 1 by r1 minus 1 by r2. Now suppose let me say this ray, both radius of curvature are same. Then what I will be getting? This ray is positive, so r1 is going to be positive for me and r2 is going to be negative for me. Incident ray is this way, so r1 is positive and r2 is negative. R1 will be plus mod r, r2 will be minus mod r. Minus of minus will become plus, so this entire thing is going to become 2 times 1 by mod r. Now generally this will be glass and this is 1 we have taken. So if this is glass, then this is going to be positive, this is positive. So focal length of this kind of thing is going to be positive when inside medium is more than when inside medium refractive index is more than outside medium refractive index. So we are going to take positive and we are going to solve it. So suppose this focal length is 50 centimeter like what we have done for mirror case. Now focal length is going to be plus 50. So suppose if this focal length is plus 50 centimeter, plot the images for the same object distances, minus infinity, minus 150, minus 100, minus 75, minus 50, minus 25, minus 25 by 2. The meaning is all the objects are real. So when there is a lens, you are putting the object here, rays are going this way, so object distance is, this direction is positive, so object distance is negative. Now I am not sure about the calculation, I just copied from some kids notes. So image distance you will be getting plus 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 plus, and here you will be getting infinity, minus 50 by 3. So what does it mean by plus? The meaning of plus is when you keep the object here, image is forming on this side. The meaning is the rays are going to actually meet. So if the image is forming on this side for lens, they are going to actually meet, that is going to be real image. If the image is forming on this side, they are not going to actually meet. When you extend the refracted rays, they will be supposed to meet here. So when the image is positive, when the image distance is on, when the image is forming on this side, that is when the image distance is positive, it is going to be real image. When the image is forming on this side, it is going to be virtual image. So whenever there is a plus, we will get a real image, real. When it is negative, it is virtual image. Now coming to the magnification, magnification is not minus v by u, this is not minus v by u, it is v by u. So when you do magnification v by u, you will be getting negative here, negative here, negative here, positive here, positive here. Now what does it mean by negative? Hi by ho is negative, the meaning is inverted. Whenever it is negative, it is inverted. The meaning of half is it is diminished, the meaning of 1 is its same size, enlarged. The meaning of plus is both are in the same orientation, erect, and the size is enlarged. Now again we have taken only real objects here because that's easy to understand. We didn't talk about virtual objects here. Now what does that mean? If you try to understand the same thing as how we have done for mirror, when you are moving the object from infinity, image started moving from 50. When you started moving the object from infinity, image started moving from 50. So when you brought it to 2 times of f, then image went to 2 times of f. 2 times of f, image will go to 2 times of f, and it will be inverted in nature. So when the object is at infinity, image is at f. When you brought it to 2f, this went to 2f. Now both the sizes are same. Now when you bring this to f, then image will go to infinity. Now when you bring this closer, image will start coming from this side, but in the same orientation. So when you are bringing the object like this, point size, then increasing its size. When it is 2f, this is 2f inverted. When it comes to f, it will go to infinity, inverted but increasing. Now when you are bringing it close, then image will be erect and it will be decreasing its size and coming. So that's the idea. So ray diagrams, generally we'll be talking about two rays. One is which is passing through the center of the lens, which will go undeviated. The ray which is parallel to the principal axis, it will meet the focus. So those two rays generally we will be drawing. The same thing here, the ray which is passing through the center will go undeviated. The ray which is passing parallel to the principal axis, it will be, after refraction, it will be passing through the focus. Anyway, they didn't draw that. The ray which is passing through the center, it will be going undeviated. The ray which is passing parallel to the principal axis, it will be meeting at the focus. Anyway, that's about the sign convention. Anyway, we have understood the sign convention. For this one, object distance is positive, image distance is, object distance is negative, image distance is positive. For this one, object distance is negative, image distance is also negative. B. For this one, object distance is positive, image distance is also positive. For this one, object distance is negative, image distance is also negative, right? and the radius of curvature. For this one, this is positive direction, so radius of curvature R1 is positive, R2 is negative, positive, negative. For this one, negative and positive. For this one, positive and negative. For this one, both are positive, right? Anyway, so the ray diagram is going to, for this table, for this particular table, we have seen different situations. So there are ray diagrams if you want to understand. When the object is placed at somewhere between infinity and 2 times of f, the image will be formed between f and 2f, but diminished in size and inverted in nature. When you bring it to 2f, image will be inverted and formed at 2f itself. Now when you bring it closer, then the image will be formed somewhere between 2f and infinity, inverted in nature and enlarged. Now when you bring it at focus, image will be formed at infinity, we don't know which infinity it is. When you bring closer to infinity, then image will be formed on this side, that is virtual image will be getting formed, right? Now you people may be understanding why I said when focal length is equiconvex and focal length is 30, with this is 3/2, radius of curvature will be 30, because you can see it here. This is 30 given and this is 3/2 given. 3/2 minus 1 is 1/2, 2 and 2 will get cancelled, so f equals to r magnitude wise we will be getting. Now talking about biconcave, again going by the same method, if this is glass and outside medium is 1, then this first radius of curvature, incident ray is going this way, incident ray is going this way, so this radius of curvature will be negative, this radius of curvature will be positive. So r1 will be negative minus mod r, r2 will be positive plus mod r. So you will be getting minus 1 by mod r, minus 1 by mod r, minus 2 by mod r. Now you can see if this is glass and this refractive index is more than 1, then this total thing is, this thing is going to be positive, this is negative, so overall focal length is going to be negative. The meaning is when you send the rays parallelly, image will be forming on this side, that is virtual image. Now again we understood focal length is going to be negative, so when the focal length is minus 50, we will see like where the images are getting formed for the same object distances, for the same object distances, and the focal length is minus 50. So you will be getting something, this is focal length and image is forming on this side, so virtual. So for the real object, image is virtual, and magnification, if you see, you will understand all will be diminished only and all will be erect only. Again we are talking about only real objects here. Now for all the cases we can go with a single figure, because we understood all are virtual images. So when the object is here, when the object is here, what image will be here and it is virtual. You need only 2 rays, one is which is passing through the center, one is which is parallel to the principal axis. After refraction it will be passing through the focus. If you notice the other figures also, we are taking only care of those 2 rays. One is passing through the center, one is parallel to axis, passing through the center, 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 parallel to axis, right? Let us see a simple question. A point source S is placed at a distance 15 centimeter from converging lens of focal length 10 centimeter. Converging lens, they already mentioned it is converging lens. The meaning is inside is glass, outside is air. So it is going to act like a converging lens and focal length is going to be positive. Where should the diverging mirror of focal length 12 centimeter be placed so that the real image will be formed? Now why we call it as diverging mirror is, you know, when you send the rays parallelly, they are going to diverge instead of converging. So let us see where the image will be formed if mirror is not there. So that is, we need to use lens formula 1 by v minus 1 by u equals to 1 by f. Incident rays are going this way, so this direction is positive, this direction is negative. So object distance is minus 15 and focal length is plus 10. So when you do that, you will be getting v is plus 30. The meaning is image will be formed at a distance 30 if mirror is not there. If mirror is not there, image would have formed at a distance 30. Now where you should be placing the mirror so that image will be formed at the same point? The meaning is rays have to retrace the path. If rays have to retrace the path, they need to hit the mirror perpendicularly. So that's the idea. If mirror is not there, then the rays would have converged at a distance 30 from here. Now focal length of the mirror is given 12. So radius will be 24. So where we need to keep the mirror of radius 24 such that the rays will be retracing the path. So we will keep it in such a way that the rays are going to hit the mirror perpendicularly. The meaning is it will pass through the center. Now for that this has to be the radius, right? So this distance is going to be 24. This distance is 24. This total is 30. So this is 24. So this has to be 6. So that's the idea. The rays have to hit the mirror perpendicularly to retrace the path. An air bubble in water behaves like a diverging lens. Now this is, you can take it like this. So here, if inside medium refractive index is more and outside is less, then it will act like this is positive, this is going to be positive, this is positive, so it will act like converging. But if inside medium is less and outside medium is more, then mu2 by mu1 is going to be less than 1 and this is going to be negative. So if this is negative, overall thing is going to be negative, then it is going to act like diverging lens. Air bubble in water behaves like a diverging lens, yes, because inside medium is less and outside medium refractive index is more. So refractive index of air is less than water, so that's the reason we are giving there also. So that's the correct explanation. Now going to the next question. The diameter of a plano convex lens is 6 centimeter and thickness of at the center is 3 millimeter. Thickness is very small, thin lens. If the speed of the light in the material of the lens is 2 into 10 power 8 focal length of the lens. So speed of the light is given. So from there you can find the refractive index to be 3 by 2, 3 into 10 power 8 by 2 into 10 power 8. So I am taking it for granted, you know the refractive index is 3 by 2. Now they have given this thin lens. This is 3 millimeter, which is 0.3 centimeter, and this diameter is given as 6 centimeter, so this is 3 centimeter. If this is the radius, then by taking this as right angle triangle, this will be root of r square minus 9. Now you know this plus this equals to total radius. This plus this equals to total radius. So from there I can see only variable is r. I can bring this 0.3 to this side and I can square it and I can solve it, and I will be getting radius is almost 15. If radius is almost 15, what is the focal length of this? 1 by focal length equals to mu2 by mu1 minus 1, that is outside is anyway 1 medium. So 3 by 2 by 1 minus 1 into, now if the rays are passing this way, this radius of curvature is going to be infinite and this radius of curvature is going to be negative 51 by r1 minus 1 by r2. You will be getting focal length as plus 30. So the key idea is getting the radius and substituting back in the formula. The next question goes like, a convex lens of focal length 40 centimeter is held, convex 40 centimeter, so it is converging, plus 40, is held coaxially above a concave mirror of focal length 18 centimeter, a luminous point object placed d centimeter above the lens. So final image is forming at the same point. Again we are going to go with the same trick. So basically this is the figure. This curvature I have drawn full and this lens I have drawn in green color. So just for easy understanding. So if you keep the object here, the rays will be going, and so if you keep the object somewhere here, then the rays after passing through the lens, they should be hitting the mirror perpendicularly. So let us see what will happen if the rays are hitting perpendicularly and going back. So you are sending the rays like this, they are hitting the mirror perpendicularly and they are going back. So instead of going with the center procedure, you are starting it from here itself. So if the rays are hitting the mirror perpendicularly while going, so if you extend them, they are supposed to meet here. Which distance is radius of this thing, which is 36 centimeter. Focal length is given 18, so 36 centimeter. So radius of this thing is going to be 36 centimeter. So let me zoom it. So if you extend them, they are supposed to meet here where the distance is 36 centimeter. This is 36 centimeter. But they are undergoing refraction here. Now this distance was given. The distance between this thing and lens is 12 centimeter. This total is 36 and this is 12. So this is going to be 24. So these are the incident rays. When you extend them, they are going to meet here. So object distance for this lens is going to be 24 centimeter. So when you use lens formula, you will be getting 1 by v minus 1 by u equals to 1 by f, and u is 24, and this is positive direction. Incident ray is going this way, so plus 24. When you substitute, you will be getting v is plus 15. So the meaning is image will be formed somewhere here where this distance is plus 15. So when you keep the object at 15, the rays will go like this, and after passing through this, you will be feeling like they are meeting somewhere here. They will hit the mirror perpendicularly and they will retrace. While coming, you will feel like they are going to meet here, but after refraction, they are going to meet here, right? So rays are going to retrace the path when they are going to hit the mirror perpendicularly. Next question goes like, two converging lenses of same focal length f are separated by distance 2f. The axis of second lens is inclined at 60 degrees. With respect to the axis of the first lens, a parallel paraxial beam of light is incident from the left side of the lens. Center of the first lens is origin. So we know when you are sending parallel rays, after passing through the first lens, they are going to meet at the focus, which is at a distance f. Now this distance is also f, but this is the principal axis. If you want to find this image, then you need to find this image, this guy's image, because we can find image of the points on the principal axis first. So we will be dropping a perpendicular and we should find the image of this. So for this, if this length is f, this angle is given as 60, so this length is going to be f by 2. So if the object distance is f by 2, we need to find what is the image distance. For that I will be using the lens formula here, and I will be getting image distance is minus f. The meaning is image is forming on the same side. These are the incident ray direction, right? So this is positive and this is negative. Image will be formed on the same side, minus f. This is minus f by 2, this is minus f, means somewhere here. So this is f by 2, this is f by 2. So image will be, this guy's image will be forming here. Now if there is some imaginary arrow, I need to see what is the length of the imaginary arrow in the image. So magnification is v by u, v by u. When you do that, magnification is twice. So we will be getting this imaginary arrow's length to become twice. The other way of saying it is, this is becoming twice. So I mean, if I look at this triangle, this length is becoming twice. So if I take this triangle, then this length also must become twice. The other way of saying it is, this other end must be meeting at the center of the lens, center of the first lens. So final image is going to form at the origin or center of the first lens. Final image will be formed at origin or at the 0, 0, and final image is virtual. The rays are not actually meeting. The rays are passing, but we will be feeling they are meeting here. They are meeting here. But if we feel like the rays are meeting this side, it is going to be virtual image. If the rays are actually meeting, they can meet only on this side. So image is virtual. It's not real, it's virtual. First image will be formed at a distance f from the lens. Yes, first image is getting formed at a distance f from the lens. So A, B, C are correct, D is wrong. Okay, going to the next question. A person can see only up to a distance of 25 centimeter. He wants to read a book placed at a distance of 50 centimeter. What kind of lens does he require for his spectacles and what must be its power? So he can see only till 25 centimeter. This is our regular problem. So if we can see only till 25 centimeter, if we want to read some object which is placed at 50 centimeter, we need to use some lens such that if you keep the object there, its image will be projected somewhere here. So object distance is 50 and image distance is 25. Now incident rays are going this way, so this direction is positive and this direction is negative. So object distance is minus 50, image distance is minus 25. Object distance is 50, image distance is minus 25. When you use lens formula, object distance is minus 50, image distance is minus 25, you will get the focal length is minus 50. Minus 50. What does it mean by focal length is minus 50? We are using concave lens. Concave lens is diverging lens, so power is going to be negative. Magnitude wise power will be how much? 1 by f, but f in meters, so that is 0.5 meters. So magnitude wise power is going to be 2, but it is diverging lens, so power is going to be minus 2. So minus 2 diopter. When you take f in meters, power is in diopters, and as it is diverging lens, power is going to be minus 2. So in the next question, the displacement method. Okay, probably I can talk little more here about power. So power of converging lens is positive, power of diverging lens is negative, power of converging mirror is positive, power of diverging mirror is negative. So if I go with power is 1 by f, if I want to define it without modulus, I can define power of the lens as 1 by f itself, because f is positive for converging lens and negative for diverging lens. But if I want to define power for mirrors, I need to define it as minus 1 by f, because when it is a converging mirror, focal length is going to be negative. So I won't be doing that thing. I will generally take power is magnitude wise, it is 1 by mod f, and I will be seeing if it is converging, power is going to be positive, if it is diverging, it is going to be negative. But if you want to use power of lens is going to be 1 by f, power of mirror is going to be minus 1 by f. So in displacement method, in lens displacement method, the distance between object and screen is 96 centimeter. The ratio of length of two images formed by convex lens is 4.84. Then they are asking some stuff. Now before that, sometimes you may have to prove this thing to understand lens displacement method. The maximum distance, the minimum distance between the real object and its real image for a convex lens is going to be 4f. That you can prove mathematically, or if you look at the table, you can see like when you keep the object at 2f, image will be forming at 2f, and that's the place where the distance between them is going to be minimum for a real image. So lens displacement method is going to work when the distance between object and screen is going to be more than 4f. we will understand why it is. So we will talk about this question from here itself, we will understand. I will say what it is. There is an object here, I have drawn it little lightly, but you can slightly manage it. Probably I will upload the PDF later. So if the object is here and screen is here, so you are moving the lens. When you are moving the lens, when it is at some particular location, you will see a good image. The meaning is image can be traced on the screen nicely. So when the object is here, image is getting formed on the screen. Now when you keep moving the lens further, now when the lens is at this position, I need to put here, but instead of putting here, I am redrawing the figure. When you are moving the lens and when you put it here, then the image will be again good. Now you need to understand, if I send the rays like this, they are going to go like this. If I send the rays like this, they are going to go like this. So basically you need to understand this figure is inverted figure of this. This figure is nothing but inverted thing of this. So that's what you need to understand. So basically if this distance is x, then this is going to be x. If this is y, this is going to be y. So magnification magnitude wise is going to be y by x here. Magnification magnitude wise is going to be x by y here. If I multiply these two, it is going to be 1. Those things you can manage by yourself. Now x plus y magnitude wise is 96. Now they said some information. Height of this one by height of this one is 4.84. So height of this image is going to be y by x times of height of the object. Height of this image is going to be x by y times of height of the object. Y by x into height of the object by x by y into height of the object. This is given as 4.84. From there you will be getting y by x is 2.2, y equals to 2.2x. But we already know x plus y is 96. So x plus y is 96 and you know y is 2.2x. You can substitute, then you will get x value, then you will get y value. So once you know x value and y value, then you can use lens formula. Y value is 66, x value is 30. So 1 by v minus 1 by u equals to 1 by f. When you substitute with sign convention, you will be getting focal length is 20.625. Focal length is going to be 20.625. Now let me put the information back. This is 96, this is 30 and this is also 30. So if this is 30 and this is 30 and this is 96, the distance between the lens is going to be 36. 30 plus 30 plus 36 is 96. So that's the idea, right? So what about the options? Focal length is wrong. Distance of the lens from the shorter image. Which is the shorter image? X by y. This is the shorter image. This is the longer image. So distance of the shorter image from the lens is 30 centimeter. Option D is correct. Distance between the two portions of the lens is 36 centimeter. Yes, we have seen. The ratio of length of object to length of shorter image. So height of shorter image by height of object equals to x by y, that is 30 by 66. But they are asking the opposite. They are asking height of the object by height of the shorter image, which will be y by x, that is 66 by 30. 66 by 30, you will be getting 11 by 5. So maybe this is the same lens displacement method. You can understand it slightly better from easy values. So what we will be doing is, there will be object here and there will be screen here. We will be moving the lens. When we keep moving the lens at certain position, image will be getting formed nicely, and at certain other position again image will be getting formed nicely. Now I am drawing it in separate figures, just like previous question. The other way of seeing it is, when the object is at this position, image is forming nicely. When the object is at this position, image is forming nicely. Now you need to understand these two figures, inverted figures. So if this distance is x, this will be x and this will be some other thing. So generally what we do is, we keep moving the lens, and whenever there is good image getting formed, we will notice that point and we will keep moving it. Whenever other good image is getting formed, we will notice that point and we will calculate the distance. We will measure the distance between them. We will measure the distance between them, and using that we will find the focal length of the lens. So we will call it as lens displacement method. We will select for what two distances we will displace the lens, and we will find for what two positions image is going to be formed, and based on that we will be calculating the focal length of the lens. Now how we will see it? So if the distance between them is 9 centimeter, and when I keep moving the lens, and for this portion there is image getting formed nicely, and for the other portion image is getting formed nicely, I can measure the distance between them, which is 3 centimeter. Now I know if this is x, this is going to be x by symmetry thing. So x plus 3 plus x is 9. From there I will be getting x equals to 3. So if I know x equals to 3, then this is going to be 6. So I can use object distance is 3 and image distance is 6, and I can find the focal length, right? So remaining things we will be seeing in the other class, right? Thank you.